Hi class, good day. Today we're going to look into chapter 7, temperature. As usual, before we start, prepare two pieces of A4 papers. The first one 7.1 until 7.3 and the second one is 7.4 until 7.6. Today we're going to focus on the first side only, 7.1 until 7.3. Three exercises only. Chapter 7, temperature. These are the three subtopics we're going to touch today: temperature and heat, zero law of the thermodynamics, temperature scale, and then next week we're going to touch about the law of the gas and equation of states, Boiler laws, Charles laws, equation of ideal gas conditions. When we talk about the temperature and heat, some might confuse between these two terms. Let us listen how Neil deGrasse he defined heat and temperature. He said that heat energy, this is the heat. Normally we use the Q to represent it, and then we measure it in joule. This is the total kinetic energy carried by all the particles inside this container. How about the temperature? Temperature is the average, only the average kinetic energy of all those particles. We can find that temperature equals to, we want to measure the average of kinetic movement of all the particles. This is the temperature. Meanwhile, the heat is measuring the summation, the total kinetic energy contains by all the particles inside that container. Let us ask Superman. He's going to heat up two things. The first one is a glass of water, 5,000 joule. And then we will notice that, wow, the water will increase its temperature from 30 degrees Celsius to 85 degrees Celsius. We give applause to Superman because he can heat up the water. And then we ask the Superman, how about use your right eye and then try to heat up the ocean? Use the same joule, 5,000. And when we go and measure before and after, we found that, oh, the increment of the temperature is very, very, very small. Let us look at one of the key concepts from this chapter, the zero law of the thermodynamics. There's a statement saying that if body A and B are each in thermal equivalent with the third body T, we can say that A and B are also in thermal equivalent with each other. Let's say A is 20 degrees Celsius, and then we have T also 20 degrees Celsius. We could say that A and B same, 20 degrees Celsius. How does the heat going to transfer itself from one object to another object? We have three ways. The first one will be the convection, conduction, and also the radiation. One day, when there is somebody bringing you the World Cup ball instead of the fireball, asking you about what is the temperature or what is the heat of this fireball, to a 6-year-old kid, he may say that, wow, this is a very hot fireball here. Then to a 20-year-old Malaysian, he would say, wow, it's a 700 degrees Celsius. To a 20-year-old American, they are not using the Celsius, they are not using the Kelvin. Normally, they use the Fahrenheit. Wow, it's 1292 Fahrenheit. When we ask the scientists will give out the Kelvin in units. Wow, it's 933.15 Kelvin. Now it's your turn. You want to write down the formula to convert K to Celsius, and then from Celsius to Fahrenheit, and then from Kelvin to Fahrenheit. After that, you are going to Google search one of the coolest place naturally in the universe is called the Boomerang Nebula. You want to show what is the temperature of the Boomerang Nebula in terms of Kelvin, Celsius, and also Fahrenheit. Remember to sketch your Boomerang Nebula too later. If we want to find a connection between the heat and the temperature, we can use this formula. The heat equals to the mass times the heat capacity times the change of the temperature. Remember the case when we asked the Superman to heat up a glass of water, and also a big ocean? Those two are from the same material. They are water. But the difference would be the mass. The water is just around 200 grams, but in order to heat up a vast ocean, I don't know what is the kilogram of that ocean. That's why when Superman apply 5,000 joule, the changes of the temperature for the ocean is very, very, very small. How about the C here? C is the specific heat capacity. For different material, we have different value. Let's say the water, we have 4180, means that we need to use 4180 joule of the energy to increase 1 degree Celsius. How about the aluminium? Aluminium will cost much lesser joule. We just take 903 joule, it can increase 1 degree too. One of the things that going to change when we apply the heat to the object is the size. We're going to see that most of the bridge going to build with a gap between the blocks from the bridge there. Why? Because the engineer found that if at the hot time, those two blocks is going to expand. And if we don't have the allowance or the gap there, those two plates going to push them together. It's like happening a small earthquake on the bridge here. That's why when we see the bridge and we drive it through and we listen, there's a pop-up sound, that it means that there's a gap, there's a wisdom that the engineer used to reduce the damage to the bridge. Just now we talked about the general idea about the expansion. Now we want to focus on the case linear expansion. It's like the pen. We heat up the pen. You want to calculate how long is the new length of the pen here. So it is equals to this formula. The changes of the length equals to the original length times the alpha. Alpha is the coefficient of linear expansion and times the changes of the temperature. So we have the table of coefficient of linear expansion of the aluminium, of the brass, copper, gold, and the iron. When we look at the number here, aluminum has the highest number. So when the number is very big, and then we have the same temperature changes here. So for the case aluminum, we will have a more longer changes. This for the case when we look at the volume expansion. Normally it happens at the liquid state. The changes of the volume will equal to the initial volume times the beta. Beta is the coefficient of the volume expansion times the changes of the temperatures. If we only have the coefficient of the linear expansion, we can use this formula. This is the beta of the gasoline, the mercury, we have the ethanol, gasoline, and the water. So now it's your turn to solve this problem. P7.2. If you ask Superman Ask him to use his eye to laser and heat up the liquid. Which liquid is much easier? Is it 10 kilograms of the honey or 10 kilograms of the water? And then you want to find what is the volume expansion of honey and water separately. And the last task is you want to watch, there's a video. It is taken from the TED Talk. The title is called Sustainable Cooling That Doesn't Warm the Planet. The author used 4 ways to help to build a better buildings. Now you want to extract that 4 good ideas into your new buildings. So idea number 1, you can get the idea at the 3 minutes and 57 seconds. The idea, you want to build a new rooftop made of what kind of material? Idea 2, it happens inside the video at 5 minutes and 28 seconds. The third idea from the authors happens at 6 minutes and 22 seconds. And the fourth idea happens at 7 minutes and 55 seconds. You want to pull all the ideas from the authors into your new house. After that, you're going to do one thing. You're going to video call with your friends, and then you're going to share your ideas with your friends in 2 minutes time. And then your friend going to share his or her idea with you in 2 minutes time. After that, that video you're going to upload into the YouTube and going to submit it. This is the schedule for today. You already scanned your attendance. You already prepared those 2 pieces of A4 paper. We just use the first piece. You already start to watch the YouTube, this YouTube. Then we end the chapter 7.3 here. After that, do download the notes if you could not hear it clearly. And you're going to start doing 7.1 until 7.3. Video call your friends. You can get your friend's name inside the Google form here. Remember to record the video between you and your friends sharing. Maximum time will be 2 minutes plus 2 minutes. And after that, you're going to upload your video to YouTube and then submit through the Google form here. Then this is the big thing going to happen tomorrow, Thursday. You're going to have your midterm exam online. You can get the link from the eCampus. At 10 o'clock, to prepare yourself. You can answer from anywhere in your hostel room, or let's say you at the cafe. Find a convenient place, a suitable place. Remember to scan your attendance. And then you're going to start answering 15 objective questions. Initially, we have from chapter 1 until chapter 5, but because of some reason, so we're going to include chapter 7.3. Means that from chapter 1 until chapter 5, 6, 7.1, 7.2, and 7.3 here. No discussion, but you can refer to the notes given to you. Download the notes, or you have the notes already by your side. So most of the questions are taken from there. You can use as a good reference. By 11 o'clock, remember to click to submit your eCampus midterm exam, or else your midterm will be submitted automatically by the eCampus. Remember to click this one this Thursday at 12 o'clock. Only given 1 hour to do so. Okay, bye.